This is FleetOps, a multi-tenant fleet management SaaS running on Azure AKS, provisioned end-to-end with Terraform, deployed through GitOps with ArgoCD, monitored with Prometheus, Grafana, and Microsoft Sentinel. Single node cluster, full production patterns. Everything you're about to see is real traffic, real data, and real infrastructure. Here's how it fits together. GitHub Actions builds and pushes the images, updates the GitOps repository, and ArgoCD reconciles the cluster. Secrets live in the key vault. Logs flow into Sentinel. Let me show you. I'm pushing a small change to FleetAPI service on main. GitHub Actions picks it up immediately. First stage, flake8 and pytest. Fatal lint errors block the pipeline. Tests run against the FastAPI app. No continue on error anywhere. A failure here stops everything. Next stage, Trivy. Static analysis on the build image. Pinned to version 0.36.0. The unpinned action was compromised earlier this year. Any critical CVE with a known fix fails the build. Right now, it's clean. Now the build and push. Image tagged with the commit SHA, never the latest in production. Pushed to Azure Container Registry, authenticated through the Azure login action with a least privilege service principal. Final stage, the pipeline checks out the GitHub repository, runs set against the values YALM to bump the image tag, scoped to the tag line only with grep verification before the commit, then pushes. That commit is what triggers the deployment. GitHub Actions never touches the cluster directly. CI builds and publishes. CD is somebody else's job. Pipeline is green. ArgoCD polls the GitHub's repo every 3 minutes. It just saw the commit from the pipeline. 6 applications, all green. FleetAPI, telemetry worker, and Postgres is managed outside ArgoCD for reasons documented in an ADR. Then Ingress Nginx, Prometheus, and Grafana. Clicking into FleetAPI. This is the resource tree ArgoCD is reconciling. Deployment, service, ingress with cert manager, annotation for let's encrypt, service account, and the secret provider class that mounts secrets from Azure Key Vault through the CSI driver. Sync history shows the rollout that just happened. New image tag, rolling update with max search 0 and max unavailable 1. The node runs close to CPU capacity, so a search pod would deadlock the scheduler. Old pod terminates, new pod comes up, done. Any manual kubectl changes gets reverted automatically. Git is the only source of truth. If I edit a deployment with kubectl right now, ArgoCD wipes it on the next sync. The cluster state matches the repo or it doesn't exist. This is the Fleet API Swagger UI, served behind Nginx ingress with Let's Encrypt cert auto-renewed by cert manager. Authentication is GWT, issued through EnterID. The payload carries a company ID claim. Every database query filters on the claim at the SQL layer. Multi-tenancy enforced in the query, not in the application logic. Get vehicles with a valid token. 5 vehicles seeded by the telemetry worker. Real rows from the PostgreSQL stateful set, running in the same namespace. Volvo, Scania, MAN, DAF, Mercedes, across 2 tenant companies. Get alerts. These are generated by the telemetry worker's simulation loop. Every 15 seconds, it writes new telemetry events and evaluates alert conditions. Low fuel, speeding, nothing is mocked. And metrics. Raw Prometheus exposition format, request counts, latency histograms, status codes, all tagged by a handler, instrumented through Prometheus FastAPI instrumentator. Prometheus scrapes this endpoint every 15 seconds automatically. Service discovery via pod annotations, no static config. This is the FleetOps API overview dashboard. 4 panels, all driven by Prometheus matrix scraped with the API pod. In the top left, we have the error rate, flat at 0, what you want to see. Top right, request by endpoint, broken down by handler. You can tell at a glance which routes carry the load. Bottom left, the one that matters, the API latency P95, not average. Average hides the worst experiences. P95 tells you what your slowest 5% of users are actually feeling. If this climbs, somebody is having a bad time, even if your mean looks fine. It's the metric you alert on. Bottom right, request rate per second, switching the range to last 30 minutes. You can see the steady traffic pattern from the worker plus my own request during the demo. The dashboard JSON lives in the GitHub repo, loaded on the Grafana pod start. No persistent volume, no manual export, survives every start. Azure Monitor Agent ships container logs and audit logs from AKS into local analytics workspace. Sentinel sits on top of that workspace as the SIEM layer. 3 scheduled KQL detection rules: brute force, privilege escalation, and interactive exec into production pods. Brute force runs every 5 minutes, counts 401s grouped by source IP, fires an incident on more than 20 failures in a window. That's the signal for someone walking credentials against the API. Privilege escalation watches the entry ID audit log for global administrator role assignments outside business hours. If somebody gets elevated to tenant admin at 3 in the morning, that's worth knowing about before the breach report. And kubectl exec into the FleetOps namespace. Any interactive shell into a production pod generates an incident. In a healthy environment, nobody executes into a pod. When it happens, someone is debugging by hand or someone is poking around who shouldn't be. Either way, you want a record of this. Everything you have seen runs out of a single resource group, the Daiberia FleetOps resource group. AKS cluster, container registry, Key Vault, local analytics workspace, the VNet with its subnets and NSGs, and the user assigned managed identity that AKS uses to pull images and read secrets. No portal clicks created any of these. It's all Terraform, modular with dependency order encoded in the root main TF. Every resource carries the same tag set: project FleetOps, owner Daiberia, environment production, and managed by Terraform. Apply from a single locals block. If a resource shows up here without those tags, it didn't come from the pipeline, and that's a signal. And this is the resource visualizer. Same infrastructure drawn from what's actually deployed. VNet feeding the AKS subnet, AKS bound to the managed identity, the identity holding ACR pool against the registry, and the Key Vault secrets user against the vault. No service principal passwords anywhere in this graph. That's the whole infrastructure reconciled leaf. State lives in its own resource group, the Daiberia TF state resource group, separate from the workload. Azure Blob backends with AID authentication, storage blob data contributor on the service principal, no account keys, no list keys bypass of airbag. The CI service principal can read and write state. Nobody else can. All infrastructure is provisioned with Terraform. Full source code at github.com/Daiberia/FleetOps.